Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. In the third Borobudur International Symposium 2021, I am Tiara Kusuma, lecturer at Universitas Muhammadiyah Magelang. I'm also student at doctoral program of pharmacy at Universitas Gadjah Mada. Will be present our original research on physical properties of nanoemulsion in water in oil types of recombinant human erythropoietin, design and optimization using the optimal mixture design. Let's see what is the most important things. Okay. Erythropoietin is a glycoprotein hormone, which is the primary regulator of erythropoiesis. Thus, EPO is used to treat anemia, which commonly used due to chronic kidney disease. And currently, recombinant human erythropoietin is available on the market in only by shop. It relates to erythropoietin as a protein-based drug, which easily dissolves by enzymes in biological fluids. Furthermore, EPO is a high molecular weight, which cannot be fully permeated from the gastrointestinal tract, and as a result, EPO causes pure oral bioavailability. In previous study, there are only few publications related to EPO developed in per-oral administration. In recent years, nanoemulsion systems have received increasing attention as an appropriate carrier system to increase bioavailability and modify drug release characteristics. Nanoemulsion are an advance of drug delivery system with thermodynamically stable dispersion. The purpose of this research was to determine the optimum nanoemulsion formula with the expected physical properties using the optimal mixture design by design expert version 13. To achieve this objective, the work steps include first, preparation of EPO nanoemulsion using high energy emulsification methods. The second, characterization of EPO nanoemulsion with measurement of transmittance using spectrophotometer, pH using pH meter, and viscosity by Rion viscometer. The third step is statistical analysis using the optimal mixture design by design expert version 13. The fourth is physical characterization of the optimum nanoemulsion of EPO involve pH, viscosity, droplet diameter, PDA or polydispersity index, and stability. And the research results show there was a lower and upper limit in the optimal design. The lower and upper limits chosen were close to the best experiment obtained from the preliminary study, and total 16 rounds were suggested by design expert version 13 using different proportion of components in total mixture 100%. The nanoemulsion will be prepared according to the proportion of the components. Initially, the oil and aqueous phase were prepared separately. In aqueous phase, twin HT was mixed with the ionized water. EPO was added into the mixture and continuously stirred for 1 minute. In oil phase, spun HT was mixed with corn oil. The aqueous phase was gradually added dropwise to the oil phase and stirred by ultrathorax for 2 minutes at 13,000 rpm. The oil used corn oil, which includes a medium chain triglyceride, which can be mixed better than long triglyceride using. And the surfactant used was a mixture of lipophilic and hydrophilic non-ionic surfactant in a ratio of 1:1 to improve stability of water in oil system. Determination the optimal formulation was conducted using the optimal mixture design by design expert software version 13. The optimal optimize the mixture of three components, which are oil, surfactants, and water, from 16 formulation in various composition. Nanoemulsion characteristic of physical properties that were used in the determination of the optimal formula is transmittant, pH, and viscosity. Based on the result, nanoemulsion was good to have a clear visual slide with a transmittant of more than 90%, and the EPO nanoemulsion had a pH ring of 6.6 to 6.91 with a significant increase in pH when they used different corn oil concentration. Nanoemulsion pH testing aims to determine the safety and release profile nanoemulsion, especially when it is used on the GI tract. And the last for viscosity determine viscosity of all EPO nanoemulsion rings from 4.2 to 6.2 with significant increase in viscosity when used different corn oil and surfactant concentration. And physical characteristic test was performed on the optimum formula with the composition of corn oil 34.6%, surfactants 55.4%, and water 10%. The area provides the prediction of the optimal formulation with desirability 0.896. And the last step to get physical properties of nanoemulsion, we characterize of the optimal nanoemulsion of erythropoietin. Besides determining the pH, viscosity, the optimal nanoemulsion, some other parameters were evaluated for further characterization, namely global diameter, polydispersity index, zeta potential, and stability. The zeta potential of nanoemulsion charts was determined by using zeta potential analyzer, and the mean of droplet size and polydispersity index of the nanoemulsion were measured by using zeta Zeiser, and based on the findings of the study, the selected nanoemulsion exhibiting pH 6.7 and viscosity 4.2. And the optimal nanoemulsion show a low mean global diameter, narrow size distribution, and zeta potential was in range. Zeta potential measures the long-term stability of nanoemulsion. When the value in modulus is small, the attractive force of the particle will be higher and can destabilize the colloidal dispersion system through flocculation. As a benchmark, nanoemulsion with a zeta potential value of 32 negatively 30 millivolt is indicative of a promising long-term stability. Since the zeta potential of the EPO nanoemulsion was negatively 25 millivolt, this indicates that the water in oil system was kinetically stable. The optimal mixture design successfully formulated the EPO nanoemulsion showing an optimum diameter 133 nanometers and PDA 0.320. The droplet diameter distribution was used as a parameter uniformity and reliability of the method of nanoemulsion manufacture. The PDF value 0.320 being lower than 0.5 is a good sign of a narrowly sized distribute optimized EPO water in oil nanoemulsion. And for the thermodynamic stability of the EPO nanoemulsion was tested at various extreme storage conditions like centrifugation and freestyle cycles. As can be seen, the optimized EPO nanoemulsion remains stable after completing the centrifugal first test and freestyle cycles. Centrifugation test is important is it gauges the product stability by an accelerated phase separation by increasing the rate of creaming or sedimentation. It's useful to predict the shelf life of the nanoemulsion under normal storage condition. The Apple water in oil nanoemulsion did not display phase separation after centrifugation at 4000 rpm for 5 minutes. As for freestyle cycle test, the Apple water in oil nanoemulsion remain homogeneous despite the extreme temperature. And for the conclusion, based on the result, we can conclude that Apple can be successfully incorporated into nanoemulsion in water in oil types. But however, this is initially studied at nanoemulsion water in oil type for Apple, which are the result is limited. It needs more evaluation to check. But it's also important to highlight here that the physical property studies indicate the very satisfactory stability at, of the Apple nanoemulsion, thus emphasizing its promising use as a double emulsion for oral delivery of erythropoietin. Okay, that's all our original research. Thank you very much for your attention. So